Hello and good afternoon. CTS265, Section 840 students for the Fall 2016 semester at Anne Arundel Community College. This is the Cisco Networking Academy CCNP route course, and this afternoon's video tutorial is going to be a video tutorial on the NetAcad lab that we completed Monday night. So this will serve as sort of your solution set and a little deeper dive. We're going to expand on some of the topics here. And this is Lab 7-1, where we're taking a look at the International Travel Agency. And so here's the topology that we have right now. All serial links, and everything has already been configured from an IP perspective in terms of the interface IPs, the loopback IP. So all of that sort of basic work has been completed. That way we can focus on the BGP portion of this exercise. So let's go ahead and dive in on the command line here. We're going to configure the ISPs first. So we're going to start with ISP1, and let's go from user exec to privilege exec into global config. And again, very simple. How do we configure BGP? We say router BGP, and then we put in the autonomous system number, remembering that ISP1 is AS200. And now we need a neighbor statement. So this is the neighbor with whom we're going to establish a BGP peering. 10.0.0.2, this is the International Travel Agency serial interface address, and they are in AS 100. So now I'm also going to advertise that loopback address network off of the ISP1 router. Again, they've got an IP of 10.1.1.1, and it's a /24. So we're going to advertise or originate that network into BGP. So do I see anything right now if I say do show IP BGP? And we do. So what do we see here? And this should look very, very familiar to you from Monday evening. And let me make sure we get the ink2go utility up here. So this should look very familiar to you from Monday evening. So what do we have here? Well, again, we start with that space character, which is still haunting me. We've got the asterisk, which is valid. And the greater than sign is best, right? So it's a valid route. It's the best route to the 10.1.1.0/24. Now remember, this third column right here, it's blank. Now, if the next hop was actually a neighbor router and this was blank, that would implicitly mean that it was learned via eBGP. However, the only exception to this third column being blank and not being an eBGP learned prefix is when the next hop is the quad zeros. So we've got the quad zeros here, and this means that it was locally originated. And we also know that it was locally originated because of the weight value that we see set here, 32,768. Remember, that is the default weight value for locally originated I was about to say IBGP, for locally originated BGP NLRI. Now, finally down here we have the path column, but again, there is no path prepended because it was locally originated. Again, you can tell that it was locally originated based off this combination of three settings here. Also recall that weight is not a BGP path attribute. It is a Cisco proprietary setting that is locally significant and not communicated to any other BGP speaker, eBGP or IBGP inclusive, right? So not communicated to any other BGP speakers. And again, we have this I down here, which is our origin code. Remember, I means that it was originated, right? Its origin was the network statement. If we had a question mark here, the origination would have been redistributed, right? It would have been redistributed into BGP. And boy, that is a terrible spelling of redistributed there, but that's what that is. All right, let's clear the screen here. And let's continue on. So we've got ISP1 has been set up. Now let's come over to ISP2. In our example, it's going to be router 7. So we'll get into global config. We'll say router BGP 300. Whoops. And we're going to put our neighbor statement in here, 172.16.0.2. And again, this is for the International Travel Agency. The remote AS is still 100. And then we're going to go ahead and originate the loopback address, the 172.16.1.0, that network, which is a /24. All right, so both of the ISPs have been configured, ISP1 and ISP2. If I say do show IP BGP, you can see that we've got the same information here, with the exception of the network, obviously, that we saw on ISP1. What if I were to say do show IP BGP summary? What do I see? Well, I see that I'm trying to establish a neighbor relationship. I haven't received any messages or sent any messages. The input queue and the output queue are 0, meaning we're not exchanging any NLRI. I'm not learning any, and I'm not sharing any or sending any NLRI updates to any neighbors. We've never been up or down, and we're in the idle state. And so what this means is we have not yet established our peering. Well, let's go ahead and resolve that issue. Now we're on to the International Travel Agency router. So we'll go from user exec to privilege exec, and then into global config, where we say router BGP 100. And we're going to say no router BGP 300. Not sure how that got in there. And then we'll say router BGP 100. Now we're going to go ahead with our neighbor statements for the neighbor router. So 10.0.0.1. And the remote autonomous system for ISP1 is 200. Now, as soon as I hit enter here, what we should see happen is the adjacency should establish. And usually it doesn't take too terribly long here initially. And there we go. And we can see the neighbor adjacency is now up. So if I say do show IP BGP. So remember, when I say do show IP BGP, I'm looking at the BGP rib, the local rib, right? But it's the BGP local rib, not to be confused with show IP route. And that shows me the global rib. This is showing me the BGP rib. And again, remember, we talked about the incoming routes that will end up in adjacency rib in. And actually, in I guess in newer hardware, newer iOS, it's actually going to be coming into the input queue, right? Where it's not actually maintaining a full-blown database of everything. It'll come into the input queue and then be sent along, unless, remember that soft reconfiguration inbound? That is where we would end up with an adjacency ribbon. But then that comes into the router. The policy acts on that, comes into the router, and goes into the BGP rib, right? And then that feeds the global rib. And then the local BGP rib feeds the adjacency rib out, which in newer releases is simply the output queue, right? Input queue and output queue. And so again, it doesn't keep a full-blown database. It just simply keeps these queues where it's actually sending the information in and out. But originally, we talk about the adjacency rib and the adjacency rib out, as well as the global rib and the BGP local rib, to sort of give you an idea as to the order of operations and the flow of updates as they come through a router. But keep in mind that really, in modern OSs and platforms, it's just the queues, right? It's not actually keeping a full-blown database for every neighbor relationship, just keeping the queues. We can also see now that we've got this next hop value here is no longer quad zeros, because remember, the International Travel Agency is learning about the 10.110/24 from ISP 1. We can see that it's valid. We see that it's the best route because, again, we've only received one. So BGP is going to select it as the best. The MED is 0. Local preference is actually 100, right? If we were to do a show IP BGP on that prefix, and we will, you'll see that it's actually 100 even though it's blank here. The weight is 0. We haven't set the weight. And here is the AS path. And now we see the originating autonomous system number, right, which is AS200. And we also know how was it originated. You've got it. That NLRI, specifically this NLRI, network layer reachability information for the 10.110/24, was originated with the network statement, because we've got the I signifying IGP. That we used a network statement that it because we had an IGP entry for that network. That's how it was originated. Interesting, EGP, this is referring to the protocol. Remember, we will not see this in the course throughout, doing our labs and things like that. But keep in mind, and this is sort of ironic, that there were some 12.4 codes where you could actually set the origin to EGP if you wanted to. Keeping in mind that when we get down to the origin code in terms of the BGP best path selection process, that IGP is preferred over EGP is preferred over incomplete. And again, older 12.4 code. I think, in fact, I have a router here. Give me 1 second here. We may be able to see this in this old, this 2610, this 12.4.16 code. I'm willing to bet that this is a code version where you could get away with this. So let's get into global config. And we're going to say route map, and we'll just say route map ABC. When I hit enter there, and again, this is sort of good that we're running across this. When I hit enter there, quick review. Is it permit or deny? And what is the sequence number? Exactly. It's permit 10. Do show run section route map. And let's see if it'll show us anything yet, or we're going to have to... Yeah, there you go. So you can see that it is permit and 10. Even though we didn't put that in, that is the default. So once I'm in here, if I say set origin, I can change the origin code of NLRI. And take a look at that. So as recently as 12.4.16 code, you could set the origin code to EGP. Now, if we took a look at a 12.4.24 box, let's get in here, get into global config, route map ABC, and say set origin and do a question mark. You can see that they then pulled it out, right? So EGP, the protocol, is historical status, not used. Again, not used practically in practical cases on the internet, but again, as recently as 12.4.16, you had the option to actually change that origin code value. All right, so let's get back to the International Travel Agency here. And like I said, we've got all of our settings here. If I were to say, do show IP BGP 10.1.1.0/24, as promised, that local preference value is 100, even though it does not show here. And the same thing with the metric, right? Metric is 0, so we get the listing of metric 0. It's valid, it's external, it's our best because it's the only one that we have. All right. So let's go ahead and finish things up here. We need to add in the neighbor statement for the ISP2. So 172.16.0.1, and the remote AS is going to be 300. And then let's originate our networks as well. These two 192 loopbacks, 192.168.0.0 and network 192.168.1.0. Now, why am I able to just simply type network 192.168.0.0 and .1.0 without having to put in the mask 255.255.255.0? Exactly. Because if I don't put the mask in here, these are interpreted as being classful network advertisements. So when I say do show run section BGP, you can see that it treats it as a classful advertisement. However, with the 10 and the 172, which are both class A and B respectively, we must put in that mask argument because we are using classless subnetting for those networks. So we need the mask argument in the command. So now we've got two pairings that are up. Do show IP BGP summary. And let's go ahead and talk about what we see here. So this is how to see whether or not your neighbor relationship is up or down, right? We can clearly see things are up. We know that we are in the established state. And again, I like working with the real routers here because the IOU, the Cisco Learning Labs curriculum, we end up, for some reason, these kind of get shifted over here to the far left-hand side. A little easier to read here. Now remember, any integer 0 or greater than 0 in this column right here means we are in the established state. You can see we've got messages going back and forth between the peers. We can see the remote peer autonomous system number. We see the BGP version number. We see the IP address of the BGP router. Now, let me ask you this. Do you think that this is the IP address of the neighbor relationship, or is it picking the loopback addresses? What do you think? Is this the router ID? That's what I'm trying to say. Is it picking the router ID? Well, let's take a look here. Let's go ahead and change things up. So I'm going to come onto router 1 here, who's ISP 1, and we are going to get into, let's get into global config and say router BGP 100, and I'm going to say, 200, router BGP 200, and I'm going to go ahead and say BGP router ID, or router ID 1.1.1.1 for ISP 1. Now take a look. It tears the adjacency down, right? Because we're now changing the BGP router ID. So just like when we change the router ID in OSPF, the adjacency is torn down and then reestablished, the same thing happens here. Let's see, does that change how things get reported? It doesn't. So what is it showing me? It's showing me the IP address to which I am peering with these neighbors. And again, that should update here. We should see an update message come through, and there we got the update message. Perfect. And that is it for the show IP BGP summary command. If I were to say do show IP route, you can see we've got some BGP prefixes. In fact, let's trim this down. Do show IP route BGP, and that's what we've learned, right? Those two NLRI, the 10.1.1.0 network and the 172.16. But what if I would say ping 10.1.1.1? All right, I've got reachability to the loopback address there. And what if I say do ping 172.16.0.1? We've got reachability there. All right, so everything looks good from the BGP perspective so far. Okay, so now what we're going to do is answer the question. It says, what is the local router ID? And we are on the International Travel Agency. So when I'm on the International Travel Agency, which is router 2, what is my local router ID? Well, how would I see that? What if I say do show IP BGP summary? Do I see my local router ID? Absolutely. And we also see the local autonomous system number. So this is a quick way to see that information. I see the BGP router ID, and I see the local autonomous system number. And it wants to know which table version is displayed. Well, it's table version 7. And each time there's an update, the table version is going to get updated. So in other words, if I were to come over here to router 1, and I were to say interface loopback 0, IP address 1.1.1.1, and we'll make it a /32, and I were to go into router BGP, I think it's 200 here, yep, and then say network 1.1.1.1 with a mask of all 255s. Let me go ahead on ITA here, and let's say do debug IP BGP updates. All right, so we're debugging updates. So we should see when the update message comes in here from ISP1, who we just originated that NLRI on. Take a look there, right? Absolutely fantastic. So let's see what we see here. We see that we receive the update with attributes, right? There's my well-known mandatory. So we'll say well-known mandatory. The origin code, another well-known mandatory. So we get the next hop value, the origin code, and the AS path. All of these well-known mandatory. These are your 3 well-known mandatory BGP path attributes. It also gives us the metric value, right? But that's not set, right? It's 0 by default. So you can see here, the 3 well-known mandatory attributes come across. and what do we receive, right? We receive this NLRI here, the 1111/32. It gets installed into it's received into the BGP local rib, right? And then it says revise route installing one of one routes to the main, and we've got the global, right? So this is going into the global rib, and this is the BGP best path selection algorithm being run sort of between these two steps right here. And if you look at the timestamp, it was like literally at the exact same time. And BGP makes the decision, hey, let's go ahead and put this into the global rib, the show IP route. So then we have the next hops on the same subnet as the BGP peer. And we get that mask information. And then that is it, right? So that is the update we received. Again, when we look at it in Wireshark doing a packet capture, it comes across as being a little bit more clear, right? We get a little better picture. Once we get into the debugs, sometimes it's a little tricky to pin down the information we're looking for because we're seeing so much information. But again, all the information that you're seeing in Wireshark, it's right here in the debug as well. And now let's take a look at the table version, because we want to know, did the table version update? And hold on just one second here. Sorry about that. Okay, so again, we see everything we need to see in the update messages. So now what we're going to do, it asked about the table version. Our version is 7. Obviously, your mileage may vary depending on how many updates you've had going back and forth. So now what it wants us to do, it wants us to go ahead and shut down on ISP1 the loopback. And what we're going to see is a withdraw message that's going to come through. In fact, what we could do is just simply say interface loopback 0 here on ISP1. That's the loopback we just created. And I could say, or actually I think I just renumbered it. Yeah, I think I actually renumbered it. And we'll just simply say shut. So we're going to shut that down. We come over here and you can see remove the forwarding route, right? So it was a withdraw update that came through. So instead of adding some NLRI to the global rib, we're going to be removing that NLRI. So do show IP route. Do we have a route now to the 1111? We do not. But let me go ahead and fix this here because I didn't realize I had overwritten, should be 10.111/24. So let's go back and interface loopback 0. We're going to say IP address 10.1.1.1, and this is a /24. There we go. All right, much better. And again, and actually I just did that on the wrong router. I apologize. Let me get out here. It should be 192.168.0. Forgot to move to the correct router, so I actually just changed that. 192.168.0.1. So let's sort this out here. Interface loopback 0. IP address 192.168.0.1, and it's a 24. And oops, let's get on to the correct router here, and let's make that change. Interface loopback 0, IP address 10.1.1.1, and it's a /24. So there we go. All right, so now things are back to the way they should be. We just shut the interface down, that loopback 0 interface, and you'll notice that it gets withdrawn, right? And did the table version, well actually the table version is going to be all over the place now. We should be much higher. Do show IP BGP summary. And our table version, you can see, is all the way up to 12. All right, so we bring that interface back up, and now they want us to take a look at the BGP neighbor table. So do show IP BGP neighbors, and again we're going to take a look at the first neighbor here, and lots of valuable information in this output. So what do we see? We see that the BGP neighbor is 10.0.0.1. We get the remote autonomous system, and more importantly, we get this external link telling me that this is an eBGP peer. If it said internal link, then obviously it would be an iBGP peer. But this tells me what kind of a peering this is. Our BGP version number. There's the remote router ID. Remember, when we say that summary command, we're seeing the IP address of the neighbor, not the router ID. And then what state are we in? Right? Is it idle? Is it active? it's established, right? And that's what we want. And in that summary command, remember, when we see under prefixes received, if it's any integer value, 0 and up, it means we are in the established state. Okay. Also very important here, right? Take a look at the neighbor capabilities. Remember, these are these attributes that get exchanged in the open message that we looked at in the previous video in the Wireshark packet capture. So route refresh, yes, it supports the new route refresh. Does it support 4-octet autonomous system numbers? Yes. It advertised it and it received that capability from the neighbor. Address family IPv4 unicast. Yes, it's advertising that it supports that and it received that from the neighbor. The enhanced refresh capability. Yes, advertised and received. And then multi-session switchover or stateful switchover, we don't have that set up, so obviously that's not going to be enabled. All right, so this is also a great way to check to see, does the BGP speaker support the 4-octet ASs? Does it support route refresh? Does it support enhanced refresh? Right? Okay. So now we're given a question here. It says, based on the output of the command, what is the BGP state? And obviously we saw that the state is established. It asked for the time and established it was up for 13 minutes and 23 seconds. All right, so now we're going to configure some route filters. All right, and this is a very, very important part of BGP. All right, and we're going to start our conversation about filtering with, I believe, simple distribute list. But now we're going to get on to, it says check the ISP2 routing table, which is going to be router 7 in our case. We'll get into privilege exec here. Say show IP route BGP. And so those are the two BGP routes that we're receiving right now. And so this leads me to believe that we are missing, let me check something real quick here, show run section BGP. Okay, we've got the network advertisement, show IP interface brief. Did I leave that interface shut down? Aha! Okay, so the reason, let me backtrack here. So I looked at this output and I'm expecting to see the 10110 network here, right? The ISP1 originated in LRI for 10.110/24, and I didn't see that. So I come over to the originator, and obviously I had changed some things mistakenly, wanted to make sure that we had everything set up, but remember we had shut that down in order to see a withdraw message. Well, now what we need to do is get back in there and make sure that we say no shut to bring that back up. We should see, there we go. We see the debug output showing me, hey, you just received a route. It's going to be installed. Here are all of the attributes that we receive that in LRI with. And now when I come over here to ISP2, there we go. That's what we're looking for, right? So when I say show IP BGP, that 10.110 should show that it originated in AS. Remember, we read this in terms of going from originator to the receiver. We go from right to left when we read it. So it originated in Autonomous System 200. Then it got sent to Autonomous System 100, with whom this router is neighbored. So we go through these two ASs in order to get to the 10.110 network. You can see the next hop value is that of the International Travel Agency, right? Okay, so now we're going to talk about, remember we talked a little bit about a transit autonomous system as opposed to a stub autonomous system. Now, if you're a company like the International Travel Agency, chances are you don't want the rest of the internet routing through your autonomous system in order to get to ISP2, right? So, and what we mean by that is right now, when we look at that routing table right there, we see something very important. We see that over here in Autonomous System 300 on ISP2, they're receiving the 10.110/24 in LRI. Now, for all of the customers over here, all of the customers of ISP2, if they're trying to get to the 10.110/24, and again, this is kind of a contrived setup. And just as a quick aside here, This is an RFC 1918 address, right? So as I'm starting to expand on the reason we're getting ready to do this distribute list, it just occurred to me that you may be scratching your head saying, wait a minute, you've told us multiple times that RFC 1918s, you can't route those over the internet. And that's true, you can't. Remember, we are in a lab environment here, right? So we're kind of using contrived, simple IP addresses in order to demonstrate something, but I think it definitely is worth calling out that we're using RFC 1918s. These would not be routed over the internet, over the public internet. But again, it's simply being used to set up this scenario. But in the scenario, if, let's suspend reality, let's say that the 10110/24 was being routed over the public internet, all of the ISP2 customers, right, and it could be millions of customers behind ISP2, and if ISP2 is Sprint or Verizon or AT&T, whoever it may be, right, all of their customers, their traffic is going to flow this direction. And you, as the international travel agency, are now a transit autonomous system. And transit because all these customers out here behind ISP2 now have to transit through you to get over here to this IP address being advertised by ISP1. And this, from a customer perspective, if you're the international travel agency, that is bad. This is not good. Because all of your bandwidth is going to get chewed up with people transiting through you in order to reach that destination network. So we're going to ensure that that doesn't happen with, and there's a number of ways we could do this. We could do an AS path access list in terms of who we're learning things from, but what we're going to do is we're going to go ahead and do a distribute list. I apologize, a phone ringing there. All right, so we're going to stop ITA from becoming a transit AS, and so we're going to be very straightforward here. So access list 1 permit 192.168.0.0, and again, we're going to do, it's going to be the 2/24s together make a /23, right, which would be 255.254.0, and the inverse of that for the wildcard mask would be 0.0.1.255. But we're permitting that to come through. And you're going to see here that the distribute list in BGP will only take an access list. We can't use a prefix list. So let's get in there. Router BGP 100. And we're going to apply this to both of the neighbor statements, right, in the outbound direction. So we're going to say neighbor 10.0.0.1 distribute list 1, and that's because that's our ACL, and then the direction. Now, how do we want to filter the updates? And again, basically what we're saying here is that ITA is only going to be advertising the two 192 networks. So it's not going to advertise the 10.1.1.1 or the 172.16.1. It's only advertising the networks for which it is actually responsible. So this would be in the outbound direction to neighbor 10.0.0.1. And then we're going to do the exact same thing for that 172.16.0.1 for the neighbor relationship there. Now, let's check to see, did this take effect? So over here on ISP2, show IP route BGP, well, I still see the 10 network. Let's come all the way over here to router 1. We'll say show IP route BGP. And I still see the 172.16.1. So what is it that we need to do here? Exactly. We need to do a refresh. Now, remember, this command right here, this do clear IP BGP star, that is a career limiting move if you do that in the middle of the production day. This is going to tear down all BGP pairings and it's going to reset them, and they're going to have to reestablish from scratch. So this is not a command that you want to do in production, but we're going to run that command right now, and you'll see, there we go. All of the adjacencies go down. We've got some debugging on for updates, so we're actually going to be seeing some update messages, and then those BGP pairings are going to come back up. So let's validate to show IP BGP summary. Yep, okay, so we're back up. If I were to say do show IP route BGP, what are we receiving? So we get the 10 and the 172, but now let's go over to our peers. And you can see right there that command, that show IP route BGP, was up there, and it had that 172, but now the 172 is gone. And this is the power of the distribute list. It allows me, the International Travel Agency, because again, remember, you have 100% full control over how traffic is routed out of your environment. However, you can only try to influence the inbound flow of traffic. But this is outbound updates, right? So I can control these as the International Travel Agency, and that is what I've done. And that's literally all we're doing here, is just making sure that we're only advertising the NLRI that we want. And this prevents ITA from becoming a transit network. So now when I say a transit autonomous system, so over here on ISP2, I say show IP route BGP, and I only see those two networks. So if I were to say show IP route to the 10.1.1.1, or 10.1.1.0, you can see that we don't have we haven't learned anything. Show IP BGP. Is there a 10 network here? No, there's not. It's gone. Because again, the International Travel Agency has gone ahead and filtered that advertisement out. So it's not advertising that in the outbound direction to these neighbors. All right, so now we're down on step 6. We're kind of wrapping up here, and we're going to be configuring some floating static routes. And let me see real quickly here if... Yeah, okay, so then we're going to originate the default. I want to make sure we were doing the default originate. All right, so we're going to go ahead and set up some static routes here on the International Travel Agency router. So let's get into global config. I'm going to say IP route with the quad zeros. And we're going to set, we'll do floaters. So we're preferring the path out to ISP1, and that's what we're doing here. So I say 10.0.0.1, and that's ISP1. Administrative distance to 210, and then I'm going to do the exact same thing over to 172.16.0.1, and we're going to set it to 220. So now when I say do show IP route, right, you can see that obviously because of the administrative distance, I'm going to be preferring the static route that takes me out to ISP1. And so, in other words, what we're saying here, and this is again controlling the routing policy. We're going to see how we're going to do that with BGP. That is my preferred path. So this is simply for all traffic where I do not have a longer, more specific match. This path is the backup, and this is my primary path over here. Again, I have a more specific match for that network, right? That's the traffic's going to come this way. But for anything I don't have a more specific match to, and all of the networks over here that I've received, the traffic is coming this way. So we're choosing ISP1 over ISP2 right now, simply because the administrative distance on the two static routes is different, and it's lower. Again, lower is better. It's lower going towards ISP1. So now we're going to set up a loopback address on ISP1, and we're going to test this default network out. So let's get into global config here, and we're going to say interface loopback 100, IP address 192.168.100.1. I want to make it a /24. All right. Now let's say do show IP. Well, actually, show IP. We're not going to advertise it into BGP. All right, so we're going to be testing on ITA here. We're going to see, does that default route work? So if I were to say do show IP route for the 192.168.100.0, the network isn't in the table. What about a do show IP ceph for the 192.168.100.0? Aha! So ceph does have a next hop value here, because ceph knows we've got this default route. So you can see, I mean, this is a very quick way to check to see is the default route actually going to work from a forwarding perspective, and it is. So let's go ahead and try that out. We're going to do, they want us to do an extended ping. So we'll say do ping and IP, we're going to go to 192.168.100.1. And then let's go ahead and we're going to do some extended commands here. We're going to say yes. And source interface, well, we're going to source it from 192.168.1.1, that being one of our loopbacks. So what could we have done? Let's just run through that real quick, and there we go. What's another way we could have done that? Do ping 192.168.100.1. Instead of going into the extended ping, I could just simply just say, because we didn't do much other than this, source it from loopback 0, or source it from, I believe we have 2 loopbacks on here, loopback 1. That would have done the same thing, right? And again, I'm not sure why they introduced the extended ping right here, but again, it's another way to do it. It's much simpler just to simply put the source in here and not have to work through all of those prompts. Okay, so now what we're going to do is typically what you would see done in an enterprise environment is you would basically work and collaborate with the 2 providers to say, or one of the 2, to say, can you just originate a default route to me, right? Simply send me a default route, because I don't need a full view of the internet table. I don't need a partial view. I simply need for you to send me a default route. And so let's do that from ISP1's perspective. And what we're doing here is, this is a scenario where the International Travel Agency probably went to ISP1 and said, hey, give us a default route, and then didn't really coordinate anything with ISP2 for whatever reason. So let's go back to the command line here. Let's jump onto ISP1, and we're going to get into the router BGP 200 neighbor statement here. So we're going to say neighbor 10.0.0.2, and what are we going to do? Default originate. So we're going to originate the default route from ISP1 router 1 to ISP2, to International Travel Agency router 2. So if I come onto the International Travel Agency here, do you think, do show IP route BGP, do you think it's here already? Do we have a default route? Right, so we clearly do not have a default route. So let's go back over here, and now we're going to do clear IP BGP star out. Right, again, that sort of soft refresh, okay, that non-disruptive refresh, that now, what do we see here? So what did we actually do here? When we talked about, you talk about those tables, right? The adjacency rib in, the adjacency rib out, or the input queue and the output queue in most modern implementations of BGP. And so what we're seeing here is I'm basically saying to all of the neighbors that ISP1 has, and again, in our case, it's a single neighbor, it's the International Travel Agency. But this command right here says, I want to resend my adjacency rib out, or the output queue. All of the BGP routing information that I would advertise, I'm resending that information to all of my neighbors. And again, it just happens to be this one neighbor. And take a look at what ends up being sent. Or I'm sorry, this is received, but it was sent from the ISP1 router, and we get our default route. So let's go ahead and say do show IP BGP. Do we have a default route in here now? We absolutely do. There it is. What about a do show IP route? Do show IP route BGP. And there it is. There's my default route. So now let's check to see, is this going to work? Do ping 192.168. What do we do? 100.1 and I hit enter. And there we go. So that is our default route out. We've got connectivity, and you're probably wondering, well, why didn't you source it from one of the interfaces? Why do you think we didn't do that? Let's look at our diagram here. Why don't I have to do that here? When I came from all the way over here on router 7, we had to source it from a loopback. And we saw how to do it up here on ITA. But on ITA, if I don't source it and I'm pinging this new loopback 100 down here, why don't I have to change the source from that? Exactly, because router 1 is going to see that the source of those ICMP packets comes in as a directly connected network. So router 1 knows who to send that traffic back to. When we did it from router 7 over here, ISP2, it showed up as a 172.16.0.1, where router 1 is going to say, I have no clue how to get to that network segment. So router 1 didn't know what to do. And that's why we had to source it. So remember that. That becomes important when you start to talk about pinging in BGP, and when you're pinging across different autonomous systems, you need to make sure that all of the interceding ASs, right, that the routing information that's going to be required to get back to you, that it's out there, right? Okay, so one final thing that we're going to take a look at is let's go ahead and set the password up between ISP1 and ITA. So we're going to say 10.0.0. Sorry, that would be 2. 10.0.0.2, and we simply say password, and I'll say ABC123. Okay, so we set the password here. We're not going to wait for it to time out, but I am going to go ahead and I am going to set it over on the other side. In fact, if I were to say do clear IP BGP star, actually, let's do this. So we're going to tear down all of the sessions and take a look at what we get. TCP6 bad authorization. No MD5 digest from 10.0.0.2. So in other words, I'm not receiving a password that matches what I have set for the International Travel Agency here on router 1. So let's go ahead and sort that out. And this is a great way to secure your BGP pairings, right? So router BGP 200. I'm sorry, we're 100. Router BGP 100. Neighbor 10.0.0.1. Password ABC123, and that's it. That's all you need to do to go ahead and secure the BGP session between your peers. And then take a look. Once we set it, look what happened. Boom. The neighbor adjacency comes up. All right. Well, this is going to wrap up the video tutorial and solution set for the NetAcad Lab 7-1 from last week. I hope this has cleared up any confusion you might have had as to, why are we doing the distribute list? I don't understand why that's getting set up. But again, it's kind of to ease us into working with policy, right, and filtering routing information. All right, thanks so much for watching. I'll see you guys on Monday night.